When we look up at the night sky, countless stars shine above us. Beyond that darkness lies a world far beyond our imagination, quietly stretching across the cosmos. What you are seeing here shows approximately 10 million galaxies. This is not science fiction. This is not CG. This is the real universe, actually photographed by humanity. An overwhelming number of galaxies, far beyond what the human eye can ever comprehend. These images were captured by the Vera C Rubin Observatory, a facility that will lead the next generation of astronomy. Now, let us witness this unprecedented view of the universe, revealed to humanity for the very first time. High in the dry mountain range of Cerro Pachón in Chile, South America, the Vera C Rubin Observatory was constructed on its summit. Earth's atmosphere distorts starlight, so the higher the altitude, the better the observing conditions. In addition, high humidity makes the atmosphere unstable, causing images to blur. For this reason, an extremely dry environment is also essential. Cerro Pachón satisfies all of these conditions and is located far from the light pollution of major cities, making it an ideal site for astronomical observations. At the heart of the observatory stands the Simony Survey Telescope. Its greatest strength is its astonishing resolution. This telescope is equipped with the LSST camera, the largest digital camera ever built. It weighs about 2,800 kilograms and contains approximately 3.2 billion pixels. To display a single image from this telescope at full resolution, about 400 Ultra HD televisions would be required. Even the famous high-resolution images of the Andromeda Galaxy taken by the Hubble Space Telescope are easily surpassed by its performance. Next comes its remarkable field of view. In a single exposure, it can capture an area of sky equivalent to 45 full moons. The 10-year time-lapse survey created from these observations will become the largest astronomical movie ever made. What truly sets this telescope apart is its revolutionary mirror design, in which the primary and tertiary mirrors are fabricated as a single integrated surface. This unique configuration allows the telescope to remain compact while enabling extremely rapid observations. The primary mirror has a diameter of 8.4 meters. Transporting and assembling these enormous components required a massive engineering effort, further delayed by the global pandemic. Finally, in October 2024, the completion of the telescope was officially announced. But the Rubin Observatory captures far more than nebulae. In these images, we see asteroids drifting near Earth, objects in the main belts between Mars and Jupiter, asteroids near Jupiter's orbit, and even bodies beyond Neptune. Some of these objects measure only tens of meters across, yet in just 10 hours of observation, the Rubin Observatory discovered more than 2,000 previously unknown asteroids. By comparison, all other observatories combined discover about 20,000 asteroids per year. That means the Rubin Observatory found 10% of an entire year's discoveries in only 10 hours. Once fully operational, it is expected to discover tens of thousands of new asteroids within its first 1 to 2 years. Some near-Earth asteroids could pose a future threat to Earth or the Moon. For this reason, the Rubin Observatory will play a vital role in planetary defense. The observatory is named after Vera Rubin, the astronomer who first provided clear evidence for the existence of dark matter. Dark matter, which cannot be seen but exerts gravitational influence, and dark energy, which drives the accelerated expansion of the universe, together make up about 95% of the cosmos. Understanding their true nature is one of the greatest challenges in modern astrophysics and one of Rubin Observatory's primary goals. It may even help solve one of the greatest mysteries of our own solar system, the search for the hypothetical Planet 9. This elusive giant planet is thought to orbit far beyond Neptune, with a period of 10,000 to 20,000 years, at a distance nearly 700 times greater than that between Earth and the Sun. Until now, detecting such a distant object from Earth has been virtually impossible. But with the power of the Rubin Observatory, it may finally be within reach. Planetary scientist Megan Schwamm has stated that if Planet 9 exists, it could be detected, or at least constrained, within 1 to 2 years. Nearly 20 years have passed since Pluto lost its status as the 9th planet. Perhaps the day when our solar system once again welcomes a 9th planet is not so far away. So what kind of images would the Rubin Observatory deliver? On June 23, 2025, the Rubin Observatory released its very first test images. Here they are. Vivid clouds of glowing gas and cosmic dust. This image is a composite of 678 exposures captured in just about 7 hours. When transferred to a computer, the final resolution reaches an astonishing equivalent of 25K. Within this single image, more than 20 known star clusters and nebulae can already be identified. For example, in the upper right, the pink and blue nebula is M20, also known as the Trifid Nebula. Located about 5,000 light-years from Earth, it is an active region of star formation. Powerful stellar winds and radiation from newly formed stars are blowing away the surrounding gas. Here is the same region as captured by the Hubble Space Telescope, where dark dust lanes dramatically cut across the glowing nebula. The massive pink cloud below is M8, the Lagoon Nebula. Situated about 4,000 light-years away, it is visible even through binoculars from Earth. This enormous star-forming region spans dozens of light-years. In Hubble's image, thick gas clouds glow like brushstrokes in an oil painting, illuminated by intense radiation. Below M8 lies a golden cluster of stars. NGC 6544, a globular cluster located over 8,000 light-years away. Despite this vast distance, its tens of thousands of stars shine brilliantly. This image combines data from Hubble and other telescopes, revealing a rapidly spinning stellar remnant known as a pulsar, emitting intense electromagnetic radiation. Above M20, a scattered group of blue stars forms M21, an open cluster containing several dozen to a few hundred stars. Compared to the surrounding nebulae, these stars are faint and small. Together, these regions illustrate the birth, evolution, and life cycle of stars. Next, we arrive at one of the most breathtaking images released so far. This single frame contains approximately 10 million galaxies. It is a 25K resolution composite made from more than 1,100 individual images. Within it lies the Virgo cluster, the nearest major galaxy cluster to Earth, located about 55 million light-years away. Spanning nearly 10 million light-years, it contains over 2,000 gravitationally bound galaxies. Every tiny point of light in this image represents a galaxy containing hundreds of millions to hundreds of billions of stars. Here we see NGC 4411 and NGC 4411b, two galaxies nearly identical in size and color, located about 50 million light-years away. Although they appear close, no clear signs of merging have been detected. Above them lies RSCG 55, a compact group of galaxies so close that their gravitational interaction severely distorts their shapes. On the right side of the image, in a dense region of galaxies, stands NGC 4261, a massive elliptical galaxy. Observations by Hubble revealed two powerful jets erupting from its core, driven by a supermassive black hole surrounded by a dust disk nearly 800 light-years wide. On the left shines an even larger galaxy, M49. With a diameter of 157,000 light-years and containing 200 billion stars, it dominates the Virgo cluster. Its yellowish glow indicates that most of its stars are older than our Sun. The last major burst of star formation here occurred about 6 billion years ago, long before the birth of our solar system. Capturing 10 million galaxies alone is an extraordinary achievement. Yet, over the next 10 years, the Rubin Observatory aims to image approximately 20 billion galaxies. There's no doubt that it will stand alongside Hubble and the James Webb Space Telescope as one of the most important observatories in history. We are now standing at the very threshold of the universe. And what the Rubin Observatory will reveal in the years ahead will surely surpass our imagination again and again.